Okay, today we're going to continue on in chapter 11 and look at the second part of that chapter, which is on a unity and diversity. That's how 11b is titled. And basically this chapter looks at the way evolutionary biologists currently classify organisms based on something called phylogeny and something called cladistics. And we're going to kind of look at how they kind of look the same, but some of the differences between them. And then we'll also take a look at the biblical way, going back to the idea of kinds and how we can look at organisms according to their kinds. So let me pull up my notes. Give me just a second. Let me rearrange my slides here. Okay. All right, so we're going to look at the idea of systematics. Systematics is the current science of classification. And we've put these together. We organize scientifically, scientists use evolutionary relationships to work these organisms into their different classification schemes. We look at phylogeny, which is trying to piece together the evolutionary history of organisms. And then cladistics is the reclassifying of organisms according to their evolutionary history. So we'll look at phylogenetic trees, and then we'll look at cladistics. And sorry, my dog just came in. You'll see maybe a little bit of how they're different. And I'll try my best to explain the difference between phylogeny and cladistics. Okay. So let's look. Now, regardless of your worldview and whether you're an evolutionist or a creationist, we can appreciate that there have been some useful discoveries with systematics. And I want to read to you some of these examples from the book that are on page 213. It says one genetic difference was discovered between the domains archaea and bacteria. One of the important differences is that they react differently to antibiotics. And that's an important fact for physicians as they treat patients with archaeal infections. Also, genetics can help us classify organisms that have been difficult to classify in the past, such as pandas. Scientists have always debated whether pandas should be classified in the bear family or the raccoon family. But the reason, you can kind of maybe imagine why they kind of look like raccoons. So phonetically, it was kind of a mix between a bear and a raccoon, but genetically, they've gone back and decided that they actually are bears. But again, this is important. Using genetic studies is important. That leads us to a lot of great information. But again, most of this is based on evolutionary worldview. And that always kind of taints how these organisms gets classified. Because if you thought that certain organisms evolved from the other, you're going to group them together, whether or not it makes much sense now or not. So let's look at this idea of a phylogenetic tree. And there's a picture of one on page 214, but I also have it here. So I'll try to go back and forth. I've got it on my slide, and also it's in your book on page 214. And the idea of this is that it shows a supposed evolutionary relationship between organisms. And these can include extinct organisms, which we can't really do any more studies on other than looking at any potential fossil finds. But when you look at phylogenetic trees, this is going back to the idea of what Darwin put together on as he wrote on the origin of species. He felt that it wasn't enough to sort and group living things into their different taxa. He also wanted to group them according to their evolutionary history. And so his tree of life tries to show those relationships. And sometimes it gets confusing, but that's what one tool that we still use today, even though we have the genetics, which tends to give us a bit of a better picture, but it's hard to do genetics on organisms that are no longer roaming the earth, the ones that are extinct. So if you look here, you can see the example that's in your book on page 214. So here's a random common ancestor. And from here, you get one branch with two kind of posts coming off of it. And then the same thing over here. And you get a seal. And then another common ancestor close to it is a panther. And then you can understand why panther and a tiger add another branch, because they're both cats. Okay. But then if you come back to the seal doesn't have another neighbor close by. But you come over here and you go to the left from that common ancestor, and then we get raccoons and foxes, and then you can kind of see maybe a better, at least by looks, at least by phenotype, what they look like. You can see how the fox could be related to a jackal and a hyena, and then how the raccoon could be related to a wolverine. But look over here, what happens? Off this raccoon branch, we do get to bears. It's just further away from the raccoon that we mentioned before. And then going over even further. Now look, this is interesting too. You've got some sea animals over here. You've got the seal over here, way far away from each other. Warthog and pig, that makes sense. They're coming off the same branch. Dolphin and whale coming off the same branch. And then cow and a gazelle coming off the same branch. Those, and they do kind of make sense in that regard as far as how do they look and how are they in some ways related. Herbivores, grazing animals, dolphins, mammals, and whales that live in the water, and a warthog and a pig obviously have things in common that we could notice if we just looked at them. But there are thousands of these because you can't include every species on the planet, every type of organism on the planet on one phylogenetic tree. So there are thousands of these. And each one is actually unique because there's not a hardcore consistency. Biologists disagree on what they think certain organisms' evolutionary histories are. So again, it's hard to tell. We don't know all the answers here. But then if you look at these branches here, okay, these branches are clades. We call them clades. Okay, so let's go back up here to our definition. These are the branches of the phylogenetic tree. And when you see those dots, let me go back, these red dots, those represent divergence. And what does divergence mean? What do you think? Divergence means an emergence of a derived trait. So what this means is once you see that dot, that's the process of two similar species becoming more and more different. So they start to separate from one another, both genetically and phenotypically. Okay, and then oh, sorry, I want to talk to you about a derived trait. So what do you think that means? A derived trait. What does it mean to be derived? Anybody got any ideas? This is really hard to do. I expect feedback, and it's hard when I don't get feedback. Okay. It's a trait that arises within one of these clades. So remember, here's a dot. So there's each branch is a clade. Okay. So it is a trait that arises within a clade and is shared by all future members of that clade. Okay, so all members of this clade, so cow and gazelle would have this certain trait, a derived trait in common. But then we have the idea of convergence. That means you have two species that are not really closely related at all, but somehow along the way, they're getting the same derived trait. So what would be an example of that? What do you think? Okay, think about animals that fly. Birds are not mammals. Bats are not mammals. Or excuse me, birds are not mammals. Insects are not mammals. Bats are mammals. But they all have the ability to fly. So insects have wings. Birds have wings. Bats have wings. They can all fly. So the idea, the development of wings, that's the idea of convergence. They are different evolutionarily, but along the way, they were able to evolve that same derived trait, in that case, flying. Okay. So you get some really interesting connections when we look at that. So let me go down here to this picture. So you see right here, the idea of convergence versus divergence. So convergence, you have bat ancestors and insect ancestors. Notice that these branches here, they don't come together at all. They're not coming from the same ancestor evolutionarily. At least that's what scientists think. Many scientists. Again, there's not always agreement. But they both have the ability to fly. So the insect can fly, the bat can fly. They're not evolutionarily related. So they have a convergence of traits. Both of them developed that derived trait of flight without sharing an evolutionary history together. Okay. Now, if you come back over here to divergence, you'll see that cattle and whale had a common ancestor. But they diverge, which means they go separate ways. Okay, they diverge, and the ability to swim comes along. Well, the whales hold on to that; they gain that, but the cattle didn't, and so now they have a different branch. Okay, so their derived trait, whatever they were related to, they still have some things in common, but the ability to swim was limited to the whales and the cattle. That this is where their similarities kind of end. Because now you have to think about, now they both are mammals still, so they both feed their young, they both make milk, they both have live births. They both still need oxygen to breathe. So there are lots of things still in common, but that ability to swim caught the whale, didn't catch the cattle, okay? Now, let's see. Again, a lot of this is worldview. So if you believe in the Earth is billions of years old and millions of years where life has evolved into more and more complex species, then your worldview and how these animals have changed over time is going to look quite different than someone with a biblical worldview. But I hope you know by now that taxonomy and classification can both be used by either biblical scientists, biblical creationists, and evolutionary scientists. They're just going to interpret things differently. And, their phylogenetic trees are going to look different. They're not going to be species and branching out. It's going to be more kinds related. And we're going to look at some examples of that. But we know too, as we've talked about genetics, we spent quite a bit of time on genetics and how useful that can be. And we just talked about that with the idea of, and we're going to talk more about archaea and bacteria and the differences between those things. But it's important because while they're both very similar in some ways, bacteria and archaea are similar, archaea are just weird. They're weird single-celled organisms, and they behave differently. And so now that we know and understand that more, we can make better drugs for people to be able to fight off infections if they happen to get infected by an archaea instead of bacteria, because there is a genetic difference. And so we can apply that knowledge and make better medicine and help people get better sooner. All right. Now, continuing on. Again, we're going to go back to this idea of baraminology where we're looking at kinds. That's more of a biblical perspective. We can do that based on genetics and physical features. So genetics and the phenotype of an organism, what we see, okay? And instead of calling it a tree of life, we're going to use the idea of an orchard of life. Okay. So in your textbook on page 216, there are several good tables and charts and pictures. I've included these here in the slide as well, but they're on page 2. These three that I'm showing you, these two, the dogs and the cats, are separate images. And then this is the third image on that page. All right, we're going to kind of look at this a little bit so you can see, hopefully, the difference. First of all, look, we're doing these kinds, dolphin kind, bear kind. And so we're keeping them, and separating them into kinds just starts to make a little more sense. It makes sense that these types of organisms are pig kinds. Now, that wouldn't be the sophisticated name for it, but for our purposes, that's what we can call it. There are better scientific names going back to the families or the orders, but you guys are not creation scientists yet. You're not evolutionary scientists yet. So some of these names, we're going to keep it simple with cattle kind and whale kind and pig kind and weasel kind. So hopefully you can just kind of get a look at this chart and see as a bit of a divergence there at each of these little, same idea, the dots still show a separation in kinds, all right? Now, if you look at, let's go to the dogs and the cats. The idea of going back to the flood and of creation itself is that a dog kind did not come from another type of organism, that dogs were dogs, whether it be a wolf or some other wolf type organism. And that was a kind that God created. And then that happened in the garden. Then the flood happened and we spared some of each kind of animal. And then they got onto the ark and they came off the ark. And after they left the ark, they had the chance to be fruitful and multiply again. And because of the circumstances of their environments, as they moved around and they were fruitful and they did multiply, they moved around, had different environments, and you get all these different types or kinds of dogs. And, oh, sorry about that. Didn't mean. And then we have the domestic dog too, branching there. And the same thing with cat. We can say the same thing, that, let me try to move this up now, sorry. That when the cats went on the ark, they came off the ark, it was some kind of cat. And then from that, we developed, as they were fruitful and they did multiply, we developed all kinds of different cats because of the variations that they were allowed to have and that God allowed them to have, and they could adapt to their environments. And then, of course, along with the domestic cat and the domestic dog, some human intervention, of course, took place too. We have the ability now to be able to breed cats and dogs and all kinds of livestock for traits that we want. So there's also, besides of natural breeding and those kinds of the natural breeding taking over and letting organisms do their thing, we also have selective breeding where we as humans select for certain traits and we let those animals breed and we get what we want from those. All right, they're still the same kind. Still we get dogs, still cats from the same kind of, same original dog kind and cat kind. Now, so just keep in mind that while we look at this, you're going to have some practice, some questions with this, and I want to lead you through one type of question looking at these kinds charts here. Just keep in mind that the first of each kind were created by God during the creation week. Remember, he created each of these animals according to their kind, and he actually paraded them. Essentially, I can imagine. I don't know if he actually, I don't know what it would have looked like, but Adam went around and named the animals. Divergence only occurs within a kind. So that an original wolf, for example, diverges into different types of dogs within that kind. And this idea of speciation, and Eliana asked me about it yesterday, and I used it again, and maybe I should stop, because your book refers to speciation. And what that sounds like is different species forming. And I'm going to actually change this. I'm going to say, instead of speciation, I'm going to say development of variation. And I obviously can't spell. Instead of thinking of it as speciation, I'm going to say development of variation, because if we're talking about not really having all these new species, but of kinds, and that those different variations within the kind, or just variations because animals adapted, let's just stick to calling it the development of variation. And it's a speedy process. It can be a speedy process. And then convergence, that idea that these organisms, even though they don't seem to be genetically related really, have similar abilities like flying. We can think of that as a creator using his creativity and giving that ability to various animals. Doesn't need to be an evolutionary proof. It can also be proof that the creator was creating things, kinds with similar functions and abilities. Okay, now on page 217, there are going to be a list of the top 5 questions I'm going to have you do, and that's going to be in the assignment portion. But there's also questions 6 through 8 that refer to this diagram. So when you look on page 217, you're also going to see this diagram. And then there's directions there that says use the clade diagram. Remember, the clade are those branches off of the tree. So the clade diagram to answer questions 6 through 8. So I would actually like to go through those with you. So get your book right now. I'm going to pause for a moment, let you get your book if you don't have it out right now, and turn to page 217. You can always hit pause if you haven't had a chance to get it. But once you get it, your book, page 217, let's look at question number 6 together. It says, according to a naturalistic worldview, which animal is the evolutionary ancestor to all the other animals? Now, again, this is just a snippet of a type of phylogenetic tree. Okay. There are, remember, we have thousands and thousands of these things because there are so many different types of organisms. Okay. So which animal is the evolutionary ancestor to all the other animals on this phylogenetic tree? So if you look down, what is the one where everything else is branching off of? And that would be right here, the Paleomastodon. Okay. Then the next question is, what 3 animals diverged and did not continue to evolve into modern day elephants? Okay, now look right here. Let's follow the branches. So when you leave Paleomastodon, there are 2 ways you can go. You can go right or you can go left. But if you go left, it stops. There are no more branches here. So this does not go on to become an elephant. There's nowhere else for it to go. So the Stegodon did not evolve, and again, we're using the word evolve because this is a phylogenetic tree, did not evolve into an elephant because that branch stops here. All right. Now let's go up on this path. There is a branch here, and we can go right, and it keeps going. We can go left, but it stops. All right, so it stops at the Ananchus. So that would be another one that did not lead to become an elephant because there's no branch coming off of it there. All right, and then the third one, we just keep going up. Well, we're only left with one other choice. So here's the elephant. And here's the Mammuthus. Okay, so the 3 that did not become, the 3 phases where, or stages levels where it did not evolve into an elephant were the Stegodon, Anankus, and Mammuthus. All right. Now, look at number 7. According to a biblical worldview, how should the 3 divergent animals be classified? Okay, so this one, these 3 right here, would we consider them all completely separate species from a biblical worldview? They would all still be considered part of the elephant kind. They are just, these organisms that were a part of the elephant kind just became extinct along the way. Now, the biblical worldview doesn't say anything about organisms becoming extinct. Organisms become extinct. They just do for many various reasons, whether there's humans or not involved. Okay. So they either, so you would say that they became extinct, but they're still a part of the elephant kind. Does that make sense? Send me an email, shoot me a comment in the assignment if you're not sure about what I mean by that. And then lastly, if you took the straightforward interpretation of Genesis 1, meaning 6-day creation, rested on the 7th day, God created all the animals according to their kinds, how long did it take for the first created kind of elephant to produce the variety of elephants that we observe today? And how does this timeline compare to an evolutionary one? Now, I want to refer you back to page 216, below those charts and to the right of the charts. So there are 2 paragraphs there. And I'm just going to take a moment to read some of that to you so you can kind of get an idea for this question. Okay. So from a straightforward reading of Genesis 1, we can conclude that each group of common ancestors, the first of each kind, so in this case, something like the Paleomastodon, was created by God just a few thousand years ago. God records in Genesis 1, 11 through 12, that he created several kinds of plants, specifying that they would continue to produce after their kind. And then along in Genesis 1, 21, 24 through 25, the Bible says the same thing about the different kind of animals. This means that the first pigs God created produced a variety of pigs in a short amount of time. It also suggests that you did not get whales emerging from pigs over millions of years. All right, so read through those 2 paragraphs, and then you can read a little bit about the biblical worldview of divergence, how divergence only occurs within a kind. And then on the next page, what about convergence? The same trait appearing in very different creatures is evidence of a design by a designer who chose to give certain traits, such as the ability to fly, to a wide array of organisms so they could thrive in his world. Okay. I am going to close there, and we did kind of rush through this chapter. So what I'm going to do is you're going to answer questions 1 through 5 on page 217. And then I want you to, you don't have to answer them because we did just go over them, but I want you to review questions 6, 7, and 8, especially question number 6 on reading these phylogenetic trees, because I want to make sure you can do that. So I want you to read, try and just make sure you understand question number 6. And then that is the end of this chapter. And as you know, the quarter is coming to an end on Thursday. I'll have an activity for you on Wednesday on dichotomous keys. You'll watch an intro video to dichotomous keys. And then on Thursday, I'll have a different assignment, but we will not start until next week. All right, I will talk to you guys soon.